All right, we're back. We're on page 303. If you're watching these videos in order, you just watched me really struggle with a product rule on a pretty basic product rule problem. So we now know how to find the derivative of product, right? So that's like f times g, or first function times second function. Derivative of product is first derivative of second plus second derivative of first derivative of second plus second derivative of first. Say it over and over. The more you say it, the faster it gets into your brain. Never forget that, right? So if you have a product, use the product rule. Makes sense. What if we want to find the derivative of a quotient, right? So this is going to be a little different. So again, we're not going to prove it. There is a proof probably in the playlist. Go to Turk's vids and search proof of quotient rule or whatever. You'll definitely find it. There's like a magic step when you find this derivative, when you do the proof of it. So it's actually like a kind of interesting proof. So I do recommend that you like check it out, but you don't need it to use it. And so that's why we're going to skip it, because there's enough going on, right? Here we go. The quotient rule. If f and g are differentiable functions, then their quotient is differentiable as long as g of x is not 0, because you can never divide by 0. It's always going to be a problem, blah, 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 right? Dividing by 0, can't. Not even once. All right, so the derivative of f over g is g f prime minus f g prime all over g squared. But that's not how anyone really says it. But let me do some highlighting here. So we got, all right, so f, and we got, I'm gonna use a different color, g. Okay, so it's gonna be that, and then it's that prime, and then maybe I should have just changed color when I shouldn't have. That, I want to go back and really highlight that minus sign there, and then there, and then really the killer thing on this that you gotta remember is, I just made my highlighter a lot smaller, is that minus sign there. So what size highlighter was that? I think that. Okay, so you got to really remember that. Here's how you actually say it though, and it's written below here. So it's going to be bottom. And then what I usually say, I don't say of the, I just say derivative top, and then minus, and then it's going to be top. This is annoying. Don't worry. When I'm done, I'm going to say it like 50 times really fast. Derivative bottom, then all over. So what color should I use for that? All over. Highlight it. All over. Nope, too much. All over. And then this is like not my strength, this highlighting nonsense. Bottom squared. Okay, so say it with me. Okay, here we go. Bottom derivative top minus top derivative bottom all over bottom squared. Bottom derivative top minus top derivative bottom all over bottom squared. Bottom derivative top minus top derivative bottom all over bottom squared. Bottom derivative top minus top derivative bottom all over bottom squared. Usually when we have class, I make everyone in class say that once. Like you have to just go around like you, and like all the way around. So please say it several times, get it into your brain, and then once it's there, you'll never forget it. I don't really know who came up with this. I'm going to guess Leibniz. Probably Newton knew it as well. Newton did a lot of things like slightly harder than maybe they needed to be done because he was like just next level. But anyway, so you can never divide by 0. Obviously, that's going to be a problem. So let's see if we can do this. So we want to compute the derivative of this thing. So what does this look like? We have a quotient. It has a top. It has a bottom. All right, so the derivative of this is going to be f prime of x is bottom derivative of the top minus top derivative of the bottom all over the bottom squared. All right, let's do our highlights. Bottom derivative of the top minus top derivative of the bottom all over bottom squared. So it's bottom derivative of the top minus top derivative of the bottom all over the bottom squared. Bottom derivative of the top minus top derivative of the bottom all over the bottom squared. And now let's simplify this. So it's x plus 1 minus x over the quantity x plus 1 squared, which is 1 over the quantity x plus 1 squared. Okay, not bad. And that's it, right? So bottom derivative of the top minus top derivative of the bottom all over the bottom squared. So if you see a quotient, use the quotient rule. If you see a product, use the product rule. If you see a power function, use the power rule. Sum or difference, use the sum or difference rule. There's a lot of rules, and they each, like, their name basically tells you what to do. So as soon as you know them, you're good to go. All right, let's do this. Evaluate d dt. So that's telling you that t is the independent variable, and you're going to find the derivative with respect to t of whatever's in parentheses. So this is a quotient, so we're going to use the quotient rule. So there's going to be a bottom and a top. Okay, so it's going to be, I don't know what to write here. I guess it d dt of radical t. Actually, radical t is terrible, right? T to the 1/2 over t squared plus 5. Okay, here we go. Bottom, derivative of the top, which is kind of gross. 1/2 t to the negative 1/2 minus top, t to the 1/2. Derivative of the bottom, all over the bottom squared. All right, should we highlight? I guess so. So it's bottom derivative of the top minus top derivative, what? Minus top derivative of the bottom all over the bottom squared. Bottom derivative of the top minus top derivative of the bottom all over the bottom squared. Okay, bottom derivative of the top minus top derivative of the bottom all over the bottom squared. So let's simplify as much as possible. All right, the way I like to do these is I like to just work on the numerator. These usually simplify in sort of a magical way, as in, like, despite all appearances, it's just gonna, like, work out, like, amazingly. So let's see if that happens. So I'm gonna write the first thing, t squared plus 5, 1/2 t to the negative second, as one fraction. So that's gonna be t squared plus 5 over 2t to the 1/2. And then minus 2t to the 3/2, and then all over t squared plus 5 squared. Okay, so far so good. Now, in the numerator, focus on the numerator. In the numerator, what is your common denominator? It's 2t to the 1/2. So what I'm going to do is I'm going to multiply this by 2t to the 1/2 over 2t to the 1/2. And that'll give me a common denominator. So where am I going to go with this? I'm going to go over here, I think. So that'll give me t squared plus 5, and then minus 4t, right? So that's 2 times 2, and then t to the 3/2 times t to the 1/2, I'm blocking that with my face, is t squared, t to the 4/2, over 2t to the 1/2, all over t squared plus 5 squared. Okay, let's simplify that a little more. So I get negative 3t squared plus 5 over 2t to the 1/2 t squared plus 5 squared. So that's our derivative. That's the derivative with respect to t. Should we check it on a calculator? Probably. It's always a good idea to check these. So you're getting, like, an insight into what I choose to do. So in a class with 30 students, there's usually not 30. In a class with like 20 students, someone will have done it independently, and they will say, I got something different. And then I'll be like, ah, crud. And then we'll go back and we will try to rectify that. But when you're on your own, you kind of have no choice but to, like, check it on your own. So here, t squared plus 5. All right, what do I get? Negative 3t squared, negative quantity. I don't know why it does that. 3t squared minus 5. Okay, and I had negative 3t squared plus 5. That's fine. Then in my denominator, I had 2t to the 1/2 quantity. Yes, nailed it. All right, so that's good. Let's go back and let's do the next question, because there's only one question left on the page, so it feels like the right thing to do. Okay, so good. We're pretty successful so far, right? So find an equation of the line tangent to the graph of f of x equals 3x squared minus 2 over 4x cubed plus 1. That's a quotient. Going to use the quotient rule. at x equals 1. All right, so there's a key thing in this question, though. It doesn't say to find and simplify the derivative. It just says find the equation of the tangent line. So what I'm going to do is I'm going to use a quotient rule to find f prime of x, but I'm not going to simplify because it doesn't ask me to. That's like a really crucial thing. So let's see. We're going to have, there's a bottom and there's a top. Okay, so we're ready. Here we go. F prime. Where can I put this? Okay. F prime of x is bottom 4x cubed plus 1. Derivative of the top, 6x, minus top, 3x squared minus 2. Derivative of bottom, 12x squared. All over 4x cubed plus 1, which is the bottom, squared. Okay, let's do our highlights. Let's do our highlights. All right, first, derivative of the second, minus second derivative. What am I saying? It's bottom derivative of the top, minus top derivative of the bottom over the bottom squared. I feel like I was saying it wrong, and my brain like wouldn't really let me go. Like that little nagging voice was like, "You're definitely messing up." All right, so bottom derivative of the top minus top derivative of the bottom all over the bottom squared. Let's say it one more time. It's bottom derivative of the top minus top derivative of the bottom all over the bottom squared. I think that's good. Okay, we are not asked to simplify this. We are asked to find the tangent line. Let me highlight this in some weird color. We're asked to find the tangent line at x equals 1, right? We're not at, is this the same color? Basically. We are asked to find the tangent line at x equals 1. Not find the derivative, simplify the derivative, find the tangent line. So let's just, from here, find f prime of 1. F prime of 1 is, okay, so 4 plus 1 is 5. 6 times 1 is 6, minus 3 minus 2 is 1. 12 times 1 is 12, over, and then 4 plus 1 is 5, and then squared. Okay, so that's 30 minus 12 is 18 over 25. So we didn't have to simplify the derivative, so don't spend your time doing that. Only do that when necessary. I do need to find f of 1, though. So f of 1 is going to be 3 minus 2 is 1 over 4 plus 1 is 5. Okay, so tangent line. Oh my God, what happened here? It's like when it gets zoomed in too much, my handwriting gets even worse. Tangent line. So it's going to be y minus, what do we get here? 1/5 equals the slope, which is 18/25 quantity, x minus 1. All right, so is the right thing to do to check in on the calculator? Yeah, it is. So let's do that. So here we go. Switch to the calculator. Okay, so f of x is 3x squared minus 2 over 4x cubed plus 1. Okay, we need a derivative. So derivative with respect to x of f of x. With respect to x means x is the independent variable. We throw the function of x in there. And then I just needed x equals 1. I get 18/25. The warning, the domain of the result is probably bigger than the domain of the original. There you go. That's the warning you get all the time. Also, because I need a derivative at a point, I could have done menu for 2, and then I would have said variable is x, value is 1, first derivative f of x. Either way, doesn't make a difference. F of 1 is 1/5, so we got it right. We got the right y value, we got the right slope, we wrote a tangent line, killing it. All right, so I think we're done with this page, and it seems like a great time to stop. So what I'm going to do is wrap this up here, and I will come back in the next video, and we're going to keep going. So I think we're doing a good job. I hope you're keeping up. If you have questions, make sure you're asking them, and I'll see you in the next video.